Okay. All right. So vapor pressure lowering is directly proportional to the solid concentration. Okay, so let's take an example. How do we calculate it? So I'm giving you guys an example. The ethanol, this is example. Let's see if we can fit into this space. If not, we'll go to next page. Ethanol has a boiling point of 255 degrees Celsius. Now, as a result, we know that eugenol vapor pressure is very low. And it is considered to be non-volatile. Non-volatile. Now we need to find out what is the water vapor pressure lowering. Vapor pressure lowering at 20.0 degrees Celsius of solution. Let me go to next page and then we'll come back again. Of solution containing 8.56 grams, this is a point, 8.56 grams of eugenol in 50.0 gram of ethanol. Now the vapor pressure of ethanol at 20.0 degrees Celsius is 44.6 millimeters of mercury. Alright, so we need to find out first moles of solute, moles of solvent, total moles, and then mole fraction. First we need to find out the mole fraction of solute, because what equation are we using? Delta P equals X solvent, mole fraction of solvent times P0 solvent. So first we need to find X solvent. In order to find X solvent, we need to find moles of solute. Moles of solute. Okay. In here we were given 8.56 grams of eugenol. And we know that its formula weight is 164.22 grams. So we can find moles of solute. When you divide 8.56 divide by 164.22, you get 0.0521 mole. So that's the moles of solute. Now we are going to calculate moles of solvent. Okay. So here we have given for solvent, ethanol is solvent, right? And eugenol is solute. So we have 50 grams. So we need to find out moles of solvent, which is 50.0 grams divided by its formula weight, molar mass 46.08. When you calculate, you get 1.085 mole. Now we need to find our total moles, because mole fraction we need total moles, which is what? 0.0521 moles of eugenol plus 1.085 moles of ethanol. When you add them together, you get 1.137 mole of total mole. Now we need to find out X of solute, mole fraction of solute. We have eugenol 0.0521 mole divided by total mole, which is 1.137 mole. When you calculate it, you get 0.04581. That's the mole fraction of solute. And we were given P0 solvent is 44.6 millimeters of mercury. Alright, so let's see how do we calculate delta P. Delta P is X solvent times P0 solvent. We have 0.04581 mole fraction, not the solvent but it's solute here. Solute, mole fraction. And we were given 44.6 millimeters of mercury. So we get delta P 2.04 millimeters of mercury. So that's delta P.